Hello, this is Bill Kovacevic, and welcome to Module 9 of a series of 12 in this seminar. Today we will be discussing and showing retail visual identity as introduced to the industry, to the sign industry and the whole world in 1991-92. Before we do that, we'll look at what rebranding looked like before in the time I started in the industry, around 1964-65. Just about every oil company had the same formula. They focused on the primary identification, which was the pylon itself, or the equivalent of it on the building. Very little was really done in architecture. They were basically quite formulaic. They had the room, the office, the washrooms on the side, and 2 or 3 bays and that was it. That was the formulaic approach to doing and identifying service stations. Along came Texaco and Esso, and all of them, they basically followed the same formula. Most oil companies had their own design and engineering departments, and the sign industry were the beneficiaries of that. And in this CITGO rebranding, City Services as was called before, it basically shows you how all of us in the industry perform this rebranding task. We thermoform either a pre-screened, as in this case, a pre-screened graphics, and pressure male thermoformed. You'll notice that there's not a vacuum there. It's essentially male, female to get that crisp detailing and assure uniformity of thickness. Once they were cooled, sometimes they were annealed. They were spray painted for the diffuser white, and it was then assembled into the aluminum casings, and from that point, it's shipped. Here's another example of a rebrand from BP. They were not all 3-pole pylon signs. These are essentially for highway locations. This is what we're really going to be talking about. It's RVI Shell. Shell called this originally the Awana program in 1990-91. Awana is a small town out of Tokyo, and the reason they held it there is to be away from prying eyes, and they kept it as confidential as possible. That was to finalize the concept of retail visual identity. That's what RVI stands for. And the concept was, and it has since changed dramatically, the oil business, that's shifted dramatically in terms of on emphasis in how they market the product. What it basically means is that rather than just focusing on changing signs, they were going to have a uniformity, and a uniformity that would be even throughout the world, the same image, the image of the shell throughout the world. It introduced some very, very original concepts in fabrication. Most importantly, what you see here on the road sign, the top section is made, the faces are processed from CPM or cold press molding, and the gray panels, the lower panels, are out of SMC. SMC, to bring it closer to describing it, SMC stands for sheet molding compound. And if you can recall the Saturn cars that have since disappeared, they were made out of sheet molding compound. In essence, an all-plastic car. What you see here is preceding RVI program, which was essentially shell on a flexible substrate wrapped around the whole canopy. It was rather blah, and they wanted to get away from it. And as you can tell, the architecture was quite ordinary. RVI attempted to get an image that incorporated architecture, signage, but most importantly, uniformity of color. You'll recall in the preceding segment I talked about metamerism. That is the same color, but on different surfaces, you had the possibility that you would get a different hue entirely. In Addison, the company that was assigned, the design firm that created this look and created the specs, they made certain that they had uniformity of color, and they insisted on a specific gloss factor, around 60-62%, to assure that whether it's vinyl, acrylic, or whatever, on site, on whatever substrate, that they would have homogeneity of appearance. This shows the road sign in an exploded fashion, and the top portion is male-female formed pectin. That's the name for the shell logo. It is retained within a CPM cold press molding, and that is because of the quantities. Sheet molding compound is for the lower panels because there were more of them. Hence, the cost of that mold was justified. In order to produce them evenly, uniformly, it was made out of sheet molding compound, SMC. Since there are daylight corner laws throughout North America, and the center pole and flagpole signs were important because you could not put a monolith that would create an obstruction to traffic, hence the center pole and flagpole versions, but also made with the CPM at top, and the lower gray panel that hid the attachment was out of SMC. This shows you the maintenance sequence, and the reason I show you the maintenance sequence, this is a sign ahead of its time, because it would have been ideal as an LED illuminated sign, but since we had to use fluorescence still in 1991, and we had to service them regularly and relamping after 12,000 hours, it was an operation. But because we incorporated certain features to allow for the sliding down these units, all these modules are literally slide up and down because they were connected. And the reason they were, Addison had an obsession. They absolutely did not like any light leaks, and we in fact won the competition. We were finalists in the competition because we were able to eliminate light leaks. CPM and SMC have the same coefficient of expansion as aluminum, and that's why it is so stable, and it works well in this context. We didn't have any expansion issues, and we were able to perform this task relatively easy. When we designed this program, we had a very thick Bible, a text that Addison spent a lot of time testing and validating all the recommendations to the contestants, and this was really a contest of who's going to build the best product, and would we recommend any of the materials that they had tested. We put our money on CPM and SMC, and as a result we won. Our competitor and finalist in the program had selected Altair Plus. The unfortunate thing with Altair Plus, it could not achieve the radius corners, the very sharp corners that Addison had specified, and hence that's how we won. This is wordless instruction that you see on the screen is the result of problems in delivering these to Caribbean sites where people didn't speak either French or English or couldn't read drawings or plans. So we made it a wordless instruction. We shipped it all over the Caribbean wherever we had these signs to install, and it worked beautifully. This is another example of using a pictorial method to give instructions on how to install these signs. Where we could not put the lazy S, that's the shape that was given, the name that was given for the canopy was the lazy shaped S for the ACM canopies, and they were very straightforward canopies already on site. This was one way that we found we could ship these kits with the fluorescence. In this instance, they would have to be T8s if there were any in the Caribbean, and the simple instruction was easy to follow. The Lazy S canopies were produced by Thermal Systems out of Calgary, And there was an issue of who was going to route out and infill the plastic letters, the fabricated letters that were produced in our plant in Montreal. And the issue was, of course, the logistics of, do they send us the lazy S section that has the S, and we route it out, put it in, and ship it back so that they can ship it again back and forth. We devised the method. We drape formed a clear acrylic with the graphics routed out, and we, with a box with a proper jig, so that they could put the lazy S ACM, and with that template, the clear template over it, and those little arches that you see, that was so that we can see that we get perfectly even insertion of the letters. And we also devised, and this is the only time I really got involved in chemistry, we also devised a method for coloring the caulking around the letters once they were installed. It worked beautifully. A thermal system produced thousands of these without a hitch. In a previous segment, I showed you how we thermoformed in two parts to achieve a fully non-cemented joints. These are wraparound signs. They were thermoformed wraparound in two stages, one flat out, then mitered with a special tool, and we were able to thermoform them, thermoform the edges so that they were nice and clean. And this was the very principle of all the egress and all secondary signs on the RVI site. No visible fasteners, again, follows throughout the signs and all the formats. As you can tell, once you slide that in, the only two things that you could have are the caps with very minuscule screws, and that were countersunk. You do not even have a hint at all that there are anchor bolts. The full casing at the bottom was made out of extruded components. Again, the no visible fasteners goes right through all of them. These cantilevered signs, they had their posts were hidden. We had a casing inserted over it, and these were again wordless installation instructions. We did that as much as possible, given that very special treatment for no visible fasteners. It was an easy way to get around the issue of who does what with what. The only exception to the ACM, there was one flexible section, that was the alcove illuminated panel, and the designers insisted that that be continuous. They didn't want any seams in it. They wanted this to be adjustable on site. So I devised this extrusion that allowed that adjustment on site, just to modify it, to be able to expand it and lock it in, and then of course fasten and clip in the flexible face. And these were the instructions of the slide in, to hook it up within the alcove in a hidden fashion. Again, there was such an obsession of hiding how it was fastened and how it had to look fully integrated. It was quite successful. This is a freestanding poster carrier. Again, in some instances they were not illuminated, and this was for either retrofitting of lights or a non-illuminated version. But we had to go through everything we built, and we thermoformed these. They had to be thermoformed, these faces, and they had a curve to it so that it could help retain the paper and not show any wrinkling. Nevertheless, with condensation and the air will somehow always infiltrate, we found a clear band as a solution to keeping it taut up against the face. But everything we did, we had to test, and we went through these motions, and before we were completely secure that anybody on site can change these posters. We got involved in packaging design. We had to ship these things all over the place, and we wanted to do it as efficiently as possible. Here we've got two outriggers packaged in the same box. ready for insertion into a casing installed up on the column, pump island column. At the very end, we had to make sure that we conveyed the proper instructions on how to clean these things, and that included specifying that it had to be a car wash. RVI was a totally controlled program by the designers. The designers were so thorough that engineers and architects on staff, and I think ultimately they became, I think most of the top design firms in the world have architects on site. I jump quickly to Irving Oil because the interim have had other very similar sign programs, but Irving Oil was one of the few where we were there from the start. Mr. Arthur Irving himself had done an extensive research on sign programs, and he had target advertising, the people that were successful in giving Irving a new look. He instructed Target to work with myself. I was lent out to the target advertising people in Newfoundland to help them design this process. They had actually made clay models of everything, and they needed instructions on how this could be done. We resolved to make this out of resin transfer molding because Arthur Irving was impressed with the Petro-Canada pylons, those red bands that you see, those circular. Very impressed with it, and he insisted that he wanted something like that. And we had to go through the resin transfer molding. We were fortunate that that was one of the things we had considered for the RVI program, and we landed with CPM and SMC because of its coefficient of expansion. It was superior, and it allowed for a finish that was that would last 25 years, as specified by Addison. We came close with the Irving Oil program, and we landed on resin transfer. The difference between resin transfer and cold press molding: cold press is, as it suggests, it's a huge 300-ton press that essentially compresses the resin and the roving, that's the fiber, under tremendous pressure to achieve a perfect thickness. Resin transfer molding operates more on a vacuum basis. It has a mold, it comes down, and then it presses and puts the roving and the resin are then compounded together. This is just another view of how well these molds have to be in terms of detailing and smoothness to get that finish, that expected finish. I had to work with the engineers to develop a system for push-through, thermoform push-through letters. We decided at that time to use Vivac HT, since then discontinued by the company that produced it, Sheffield Plastics. And one of the reasons we chose this is because the designers in the question, the agency, wanted an absolutely perfectly formed, and they were very specific as to the tightness of the lettering and how it would fit in. If anybody ever takes a look at the real Irving logo, they will notice that there's a difference between what you see on the sign and what you have on their logos, on their written and their typed version of their logo. There was a slight modification made to the R in order to accommodate the thermoforming process so that we get a sharpness. This is we had originally assumed and thought that we could do it all in one, but then again, the expansion and contraction of it is we decided to insert the letters separately. We had to make sure that we had, once it's finished, that we had proper edges and finishes. It looks simple, but we went through quite a few refining processes. The next sequence shows us trying to find a simple method, a uniform method to assure, again, without any visible fasteners. We wanted this to be as clean and even looking. And what was essential is that the interlocking, or we can allow for some expansion and contraction, that it be done very smoothly so that we don't get a disjointed and a wobbly look. We developed several extrusions before settling on one that would to give us the results we were looking for. And this is, again, going back to what we did with the shell letters, who is going to do what with what. Whitewater was reluctant to be involved in assembling of letters, and they were, but the issue again of sending a panel from Kelowna to Montreal and then back with the processed one was costly. We resolved to make a kit, a lamp kit, and a template pre-made so that everything could be easily inserted at the Kelowna plant, and they would then assemble it and ship it off, saving the cost of shipping a panel back and forth. This was the test model at the Kelowna site, at the Whitewater plant. It was attended by Mr. Arthur Irving himself, and we were looking at it from every aspect. Most importantly, since I designed that chevron out of ABS with the trimless 3/8" acrylic to give it a completely frameless look. That ABS had to fit snugly within the openings that we provided in the logo panel. And the issue here was, given if you were putting that 36-inch module up against a 4-foot fascia, would it swing open, how much tolerance, and so on. It worked beautifully. We were able to determine that once it's opened, that we could access the lamps for servicing. Here's one of the crucial tests. What we were concerned, of course, is torquing of any, but that panel is so solid and so strong, and with the letters braced on the inside and a middle brace, and it wouldn't budge. There was no danger of loosening this thing. As you can tell from that angle, it's perfectly straight and taut, and it opens and gives it sufficient opening. Then the lighting tests at night, it sparkled. The LED bands, or the rings around it, were made from TIR, since long gone. They had a silicone baffled system for being able to wrap around corners. We developed a radius system from TIR specifically for the Irving program. It's still very effective. We also produced and designed with, that's the designer, Tom Murphy. We produced these harps, shrouds as they were called, along with the RTM system. And that's the group, the engineers, and Guy Frenette, my colleague in this whole project. Thank you, and looking forward to Module 10. We will have fun with Module 10. We'll be talking about the influence of architects and designers on sign products. Looking forward to talking to you again. Thank you.